This is Naveena Good afternoon, everyone. This is Naveena from the Department of Cybersecurity in the Institute of Aeronautical and Engineering, Dundigal. And I came to know that about of my previous videos and I have done based on that the routing algorithms in the network layer and the routing type of protocols and how the routing algorithms will be determined. And based on the number of routing algorithms, like the greedy type of routing algorithms, what we can call like the link state routing algorithm, shortest path routing algorithm, minimum distance for spanning tree, and distance vector routing algorithm, what we can call it as in otherwise Bellman-Ford's equation, and shortest path routing algorithm in secondary way, what we can call it as a Dirac algorithm, as well as link state routing algorithm, flooding algorithm, flow based charting algorithm, and discovering the neighboring hosts and routing for the mobile agents. We have already discussed, according to my previous videos, all the type of routing algorithms and the mode of working of the routing algorithms. And today, I came with the concept based that what it is meant for internet control protocols. Out of that one, the two type of internet control protocols. What are those two type of internet control protocols are OSPF and internet protocols. So OSPF is meant for open shortest path first, that means, and IP is meant for internet protocol. And here we need to discuss how the OSPF stands for and what is meant by the IP, what it is meant for, and the model of OSPF and the type of internet protocols, what we can call it as IP, and what are the benefits of the OSPF and what a protocol of OSPF does use, and what are the benefits of the OSPF and how does OSPF works. And after that one, mainly IP, the type of the IP addresses, that means IPv4 and IPv6, and how does the internet protocol works. So in this video, and I want to discuss based on that two type of mainly internet control protocols, the what we can call it as a OSPF as well as IP internet protocols. So coming to this, the first type of internet control protocols, what we can call it as the OSPF. OSPF is meant for the name it indicates open shortest path first. The OSPF stand for open shortest path first. It is a widely used and supported routing protocol. It is one of the routing protocol which is meant for the task of internet control protocols, and it is a widely used and supported routing protocol, and it is an intra-domain protocol. What do you mean by intra-domain protocol? What do you mean by intra-domain protocol? That means it can able to work not only between the inter-domain, means between the two sections of domain or between the two different types of domains, but here if you can identify the term intra-domain protocol, means it can able to work or between, it works from one type of intra-domain to second type of intra-domain, like the two type of domains. Here we have to identify the domain 1 and domain 2. So between intra-domain means within the domains only, within the two type of domains it can able to work, that is intra-domain protocol, not between the two type of domain protocols. It can able to work within the intra-domain protocol, within the domains. It can able to work within the domains, like internal domains. It can able to work within internal domain. So hence the name we can refer this as a intra-domain protocol, which means that is used within an area or a network, and it is an interior of gateway protocol. It has been designed within a single autonomous system. So coming to this is the definition what we can call regarding the OSPF stands for. What I mean by the second type of protocol, what we can call it as a by means of Internet Control Protocols. The first one is OSPF, second one is IP, Internet Protocol. So according to the second one of Internet Control Protocol, what we can call it as a IP. IP stands for Internet Protocol and it specifies, that means IP specifies the format of packets, also called the packets may be in the format of datagrams or data packets or bits, and the addressing scheme. Most networks combines IP with a higher level of protocol called as Transmission Control Protocol, TCP/IP. TCP/IP. TCP is meant for Transmission Control Protocol, as well as IP is meant for Internet Protocol. These two are the mainly important type of protocols which is worked under the network layer for establishes a virtual connection between a destination and a source. These two type protocols are meant for to establish a connection between a source node and the destination node. So that is the main abbreviation which is meant for IP type of protocol, what we can call it Internet Protocol. In this Internet Protocol, mainly it is the combination with TCP/IP, what we can call it is, and we have already heard based on the OSA reference model. This TCP means Transmission Control Protocol, as well as IP means Internet Protocol, and which is used to give a virtual connection or to establish a virtual path between the destination as well as the source nodes. So coming to this is one of the model architecture of OSPF. That means the router 1 and the router 2 and the router 3, the router 4. All these type of routers are fitted or associated by means of one subnet of networks which are connected by means of intra-domain within the system, and how they can able to connect. The router 1 is connected with one network connection with one network, and router 2 is also connected with the network, router 3 is also connected, and router 4 is also connected. This is one of the model of OSPF, and all these are connected by means of a centralized network, and we can able to see the way of accessing the information from router 1, from router 2, from router 3 to the main subnet of switchworks and router 4 through the RT router 2 to router 4. It can able to communicate with the personal computer or desktop. So this is nothing but the mode of how the OSPF can able to work within a subnet of networks, and what we can call it as that word intra-domain. Intra-domain of networking model we have to observe by means of OSPF model of Internet Control Protocols. So after that one, what I mean by Internet Protocols? So Internet Protocols means a protocol, if you can define, it is nothing but a set of rules. A protocol is defined, it is nothing but a set of rules. Coming to this, the Internet Protocol, it is a part of a protocol which specifies where on the envelope the delivery addresses needs to be written. If the delivery address is already written in the wrong place, the letter cannot be delivered. That means the delivery of a address can able to written it in a right place only, that it can able to deliver. If it would be placed it in a wrong place, it cannot able to deliver. And next point, coming to that Internet Protocol, is a set of rules having the communication between a computers on a network. Communication between a computers between the subnet of a network. That means that host 1, like in our previous diagram, communication between the number of networks within a subnet of networks. That's what we can call it as a communication mode of a working of Internet Protocols. Internet Protocols are set of a rules governing the communication within and between the computers on a network. network. And coming to this, the OSPF, what we can call it as the first protocol of Internet Control Protocol, another OSPF pen as divides the shortest routing path first. Open shortest path first. The OSPF is defined as open shortest path first interior, and it is an autonomous protocol system areas which is meant for autonomous protocol system areas to handle, and which is useful to handle the routing efficiently and in a manner of fine print. We can able to define this type of protocols by means of a PDF factory, that means www.pdffactory.com. And coming to this one, the OSPF allows the administrator to assign a cost, what we can call it as a matrix, to each route. That means the node to be assigned by means of a from one node to the another node. And next one, the metrics can also be measured or determined the type of this service provided by means of a OSPF. And coming to this, the third point, minimum delay and maximum throughputs we have to identify by means of a OSPF type of protocol. And next one, a router can have multiple routing tables. A router can have multiple type of routing tables we have to identify by means of a OSPF. And each based on a different type of service. Each routers based on a different type of services can be provided by means of a each type of routers. And coming to this, the OSPF uses link state routing table in a routing area. The link state routing router means the link state routing here, the router shares its updated knowledge about the process by which its neighbors with every fine print PDF factory pro router in the format of www.pdffactory.com.area. That means whenever, if you can take the example of one subnet of network consisting of number of hosts which are connected with a centralized network, what we can call, suppose the root node A, B, C, D. It is the root node. Whenever it receives the information or receives any communication or any knowledge of information, whenever a root node receives, it can able to share that information, whatever the information already received by means of a root node A, it can able to share its information to its adjacent neighbors of what we can call, we have to see here the B as well as the C and the D. So this is the type of sharing we have to recognize or identified by means of sharing the information with its neighbor under the link state routing protocol. So what a protocol does OSPF use? What it's meant for and what is the usage of OSPF? The OSPF runs over Internet Protocol version, that means IPv4, and we have already seen based on our previous videos the Internet Protocol consisting of the two type of Internet Protocol addresses, what we can call IPv4 and as well as IPv6, and but does not use a transport protocol. That means but does not meant for transport control protocol. It is meant for IPv4 as well as IPv6, such as UDP means User Datagram Protocol or TCP Transmission Control Protocol. It encapsulates its data directly in IP packets with protocol number. The protocol type of number, what is the type of protocol number? 89. And this is the way of how the protocol of a OSPF can able to work, how it can able to use it in the network layer. And coming to this, what are the benefits of OSPF? OSPF is meant for open short path first. So it will be coming like the quality of service in network layer also. OSPF provides the advantages or the benefits of OSPF if you can identify or if you can determine the benefits of OSPF, like it is having the both the IPv4 and IPv6 routed protocols we have to identify under the OSPF protocol. The OSPF protocols consisting of both the IPv4 as well as the IPv6 routed protocols we have to identify under the OSPF. And next point, it loads the balancing with equal cost routes for the same destination. That means the cost of routing paths and the cost of routes should be determined from one node to the another node should be the same. Or it will be like the balancing mode only. The load will be in the mode of a balancing mode, and hence the equal cost of routing should be determined from one source node to the destination node, which should be identified as in the same path only. That means like the VLSM and route summarization. Next, on unlimited hop counts or the benefits of OSPF. What do you mean by a hop counts? That means the ability of traveling of the data packets from one node to the another node. I will illustrate with an example. Suppose this is the E0 and this is the E1 node, this is the E2 node, this is the E3 node, this is the E4 node. And how we can able to determine the hop count means the ability of the data packet or a data frame or a data bit can travel from one node to the another node. That means the distance of a data packet can travel from one node to the another node, like E0 to E1 1, E1 to E2 2, E2 to E3 3, E3 to E4 5. So this is the hop count of between the two nodes E1 and E0, and between the E1 and E2 is the hop count of 2, E2 and E3 is the hop count of 3, E3 and E4 is the hop count of 4. This is the somewhat I want to define it clearly by means of the hop count. What do you mean by a hop count? Next one, trigger updates for fast convergence. We need to get the updates. That means whenever a source node can able to send the data, that acknowledgement will be getting by means of a destination node to the source node. Destination nodes to the source node. This is the trigger updates for fast convergence. Next, a loop-free topology using SPF algorithm. What do you mean SPF means? Shortest path first. Shortest path first algorithm. A loop-free topology using SPF algorithm. Next, run on mostly all the routers. It can able to run on mostly all the routers, and it is a classless protocol. If you can define it, the OSPF, while talking with the benefits, it is the classless protocol. Next one, how does OSPF works? And again, I have already in this video and previously I have explained based on that model of your OSPF. Like that only here, if you can recognize the OSPF here, if you can recognize this is one of the internet and connected with number of backbone areas like the R3, R1, R2, R3, R4, R5 and R6. So here the R1, it is nothing but the OSPF area, backbone area, and it is the mainly the backbone area. And next one, it is connected with the R2, what we can call it as the ASBR, and R1 again it will be connected with subroute, what we can call it as a router ABR, and here it will be connected with R4 ABR, and after that it will be connected with area 1, and after one it will be connected with area 2. So here we have to identify the routers or the backbone areas, the routers of a 6 type of routers we have to identify from router 1 to router 6. Router 6, which all should be what we can call it as the subnet of work, which are connected with the internet, which are associated with the internet. So, whenever a router R1 gets the information, it can able to transmit that data to R2, and it can able to sharing that information to the R3, from the R3 to the router R5, from the R1 to the R4, R4 to the R6, and R1 is directly associated with the internet. So like that only, and these three are which are meant in one domain, like R2, R1, R4, R3 are meant for one domain, and the R3 and R5 meant one second domain, and R4 and R6 meant one third domain. So this what we can call it as a intra-domain. Intra-domain of network we have to identified under OSPF model of working. So here how we can able to identify how the number of routers or one by one they are associated with the internet connection. Whenever a root node of R1 here receives the information or knowledge about the routing or a subnet of a works routing of a networking between the sending of the packets from one node to the another node, that information the root node of R1 can able to share between all the adjacent routing neighbors, what we can call according to this OSPF model, like R2, R3, R4, R5 and R6. So coming to this, the OSPF offers a very distinguishable feature named routing areas. What we can call routing areas. It means dividing the routers inside a single autonomous system running, what we can call it as a OSPF into areas where each area consisting of group of connected routers. Like this only. Each area consisting of group of connected routers only. This group consisting of some connected associated with number of routers. This area consisting of the two type of routers, what we can call it as R4 and R6. And this type of connected area associated with two type of routers, what we can call it as R3 and R5. This type of routers are associated with four type of routers like R1, R2, R3 and R4. So here it means dividing the routers inside a single autonomous system. What we can call it as this system, what we can call it as autonomous system. Here we have to identify different type of connected areas will be there, but the routers are grouped particular based on this each connected area, So inside a single autonomous system, the OSPF is running into areas where each area consisting of group of connected routers. So the idea of dividing the OSPF network into areas is to simplify the administration and optimize available resources. Simplify the administration as well as the optimizing the available resources. And coming to this, under the network layer and how the OSPF is meant for, why the OSPF is meant for. So why is OSPF means it is one of the best protocols used nowadays. It is one of the best protocols used nowadays because of its convergence speed and ability to choose paths based on network performance. What are the two things? Because of the convergence speed as well as the ability to choose paths based on the network performance, only the OSPF is decided nowadays. It is one of the best protocols they are using in nowadays. And OSPF is a better choice within corporate of lands and private data centers like some institutions, autonomous institutions like and education institutions, academic institutions. In some situations, OSPF can also be used for dynamically learned WAN routes and connective to LASS clouds and connected to the cloud computing networking also. So further solely people selectively using OSPF protocols nowadays in a best wide of routing. Why? Because it consisting of the two types of what we can call it as the ability of convergence in speeding and ability to choose selected paths while routing the packets from one node to the another node on basis of a network performance. On basis of a network performance. So coming to this, so under this one, mainly the internet network layer, what we can call it as the IP, the architecture of a internet network layer by means of a internet protocol. If you can recognize or define means, if you can define means the internet network layer components. What are the components which are present under the internet network layer components? Those are the internet protocol, what we can call it as the addressing, which is meant for the addressing, datagram format as well as the handling and routing of the protocols, and as well as the ICMP protocol, addressing, datagram format and handling as well as routing protocols and ICMP protocol. So if you can take this diagram, this is the network layer, and here we have to identify the routing type of protocols based on the path selection, RIP, OSPF and VZP. That now already we have discussed OSPF, open short path first. And coming to this, the IP protocol, which is meant for addressing conventions as well as the datagram format as well as packet handling conventions. And coming to the ICMP protocol, which is meant for error reporting as well as router signaling. This is one of the architecture of a internet protocol, what we can call it as the IP protocol under the network layer, consisting of the routing protocols, IP protocols as well as the ICMP protocol. The routing protocol, IP protocols as well as the ICMP protocol. So coming to this, IP stands for Internet Protocols and VP stands for IPv4. So IP protocols again consisting of the two types of, mainly it will be divided into the two types, IPv4 protocol and IPv6 protocol. Let us revise already this topic I have already discussed in my previous video. Again, I need to make a review of based on that IP internet part of a protocol consisting of the two types of protocols, what we can call it as the IPv4 as well as IPv6. The parts of IPv4 consisting of the network part as well as host part and the subnet part. The network part mainly indicates the distinctivity variety that's appointed to the network, as well as the network part conjointly identifies the category of a network which should be assigned. And coming to the second part of a IPv4 host part, it is unique identify number which the machine matches on your network. Uniquely identified number which a machine identifies on your network. This is the part of a IP4 address assigned to each and every host part. Coming to the subnet number, this is the non-obligatory part of IPv4. Local networks that have massive numbers of hosts which are divided into subnets, and subnet numbers are appointed to that according to that subnet numbers only. So this is one of the non-obligatory part of IPv4. So coming to this characteristics of IPv4, IPv4 could be a 32-bit IP address and IPv4 could be a numeric address and its bits are separated by a dot. Hence, the number of header fields is 12 and the length of the header field is 20. Number is equal to 12 and length is equal to 20. In his unicast, broadcast and multicast style of addresses we have to identify. It consisting of three type of addresses. The first one is unicast, type of address, broadcast type of address, as well as the multicast style of addresses. Hence, the IPv4 supports VLSM, what we can call it is a virtual length subnet masks. And second one, the IPv4 uses the post address resolution protocol, ARP, to map the MAC addresses. And resolution internet protocol may be a routing protocol supported by means of a routed daemon, and it works ought to be designed either manually or with the DHCP. And packet fragmentation permits from routers to the posting state. Packet fragmentation should be divided from routers to the posting host. These are the characteristics of IPv4. That means mainly it should be holding 32-bit IP address consisting of numeric address and header fields. IP bit address, numeric fields, as well as the header fields. Coming to this, the advantages of IPv4. IPv4 security performs the encryption to keep up the privacy matters, like which gives the privacy issues like the privacy as well as the security issues. Coming to this, the IPv4 network allocation is significant and presently has quite 85,000 of practical routers it will be connected with overall the world. And third one is it becomes easy to attach multiple devices at a time across the total outsized network, while it will not be by means of a NAT. And fourth one is this is the model of communication to provide the QoS, quality of service, according to the economical knowledge of transfer. Coming to the next point, IP4 address are redefined and permit flawless encoding. It is meant for redefine the addressing of a protocols and permits flawless encoding. That means routing is a lot of scalable and economical as a result of addressing is collective more effectively and efficiently. Routing is a lot of scalable and economical. And after that, last point is data communication across the network becomes a lot of specific in multicast organization. Data communication across the network becomes a lot of specific in multicast organization. And coming to this, why IPv4 has the limits net growth for existing users and hinders the use of the network for banned new users. And internet routing inefficient is IPv4. Why? Because it has high system management prices and it's labor intensive, complex, slow and frequent of to errors. So it is somewhat inefficient comparatively with the IPv6. Why? Because it is having high system management prices and it's labor intensive, complex, slow and frequent to errors. And after that one, it is security features are non-obligatory. Next point is different type of future support for future designs as a result oriented of adding it on a extremely high overhead since it hinders the flexibility to attach everything over IP. And coming to this, the IPv6 addresses, the IP address is your digital identity and it's what we can call it as a network identity, or which should be consisting of network address and the header files. So IP address is your digital identity and it's a network address for your computers, so the internet knows where to send you emails and to data to other hosts, to other nodes. And next one, IPv6 or Internet Protocol version 6 is a network protocol layer which allows communication to take place over the total subnet of work, which can take place over the communication which should be meant or it takes place over the total type of network. So IPv6 means it is the version for V6. Version of IPv6 means Internet Protocol version 6 is a network layer protocol which allows the communication to take place over the network. And again, the IPv6 address consists of 8 groups of 4 hexadecimal digits. Here is an example of IPv46, that means 3001 and 0DA8 75A3 0000 0000 8A2E 0370 7334. This new IP address version is being deployed to fulfill the need for more internet addresses. And it was aimed to resolve issues which are associated with the IPv4. IPv6 is meant for to aim the corrections or resolve the issues which are associated with IPv4. With 128-bit address space, it allows 340 undecillion unique address spaces. With 128-bit address spaces, it allows 340 undecillion unique address space. So IPv6 is also called as IPNG. IPv6 is also called as IPNG. That means Internet Protocol Next Generation. Internet Protocol Next Generation. So coming to this, what are the type of IPv4 addresses? It supports a theoretical maximum of 340, 280, 360, 290, 938, 463, 463, 374, 607, 431, 768, 211, 456. To keep it straightforward, we will return some out of IP addresses again. What are the type of IPv6 addresses? Means as well as unicast address, multicast addresses and anycast addresses. Unicast addresses means a unique node of network might be identified and usually refers to a single sender or a single receiver. That means single sender, single receiver. We have to identify it under unicast address. Coming to that multicast address, it represents as IP devices can only be used as a destination of the datagrams. Single sender and multiple receivers we have to identify. Coming to this anycast address means it is assigned to a set of interfaces which typically belongs to different nodes. Like the number of nodes we have to identify by means of a one path. Like it is a set of interfaces which typically belongs to different nodes. Coming to this, the advantages of IPv6, it is having the reliability, fast speeds comparatively with IPv4. Fast speeds, that means IPv4 supports multicast rather than broadcast in IPv4. This feature allows bandwidth-intensive packet flows like multimedia streams to be sent to multiple destinations at the same time. Coming to this, the second advantages of IPv6 is stringent security. Stringent security means it is one of the security like what we can call it as IP security, which provides confidentiality and data integrity is embedded into IPv6. Coming to this routing efficiency, most importantly, it is the final solution for growing nodes in global network. Routing efficiency means it is the final solution for growing the nodes in worldwide network. So these are the three advantages of IPv6 when comparatively with the IPv4, what we can call it as a faster speeds, reliability, stringent security as well as the routing efficiency. So coming to this disadvantages of the IPv6, the conversion. Due to the widespread present uses of the IPv4, it will take a long period to completely shift to IPv6. That means people, they are inherited or inhabited to use it, habituate to use the IPv4 as usually, and it will take a long period to completely shift to use the IPv6 addresses. So coming to this communication part, IPv4 and IPv6 machines cannot communicate directly with each other. They need an intermediate technology to make that possible. So, and at the end of this video, based on this internet control protocols, and the students can able to learn, that means this video outcomes should be the type of the internet control protocols, that what we can call it as a OSPF, as well as the IP, and how the OSPF work, what are the benefits of the OSPF, and why the people they are preferring the OSPF, what are the advantages of the OSPF, and what it stands for, and the model of a OSPF, and how the OSPF can able to work. And after that one, coming to this internet protocol, what do you mean by IP, and how the internet protocol is playing a vital role under the network layer, and why it is so important under the network layer. What is the type of combination of a protocol associated with the internet protocol, what we can call it as a TCP, IP, what we can call it as a transmission control protocol, as well as internet protocol, and what are the type of addresses, IPv4 addresses as well as the IPv6 addresses. Coming to the IPv4, and what are the benefits of the IPv4, what are the types of IPv4 addresses, and how long the IPv4 addresses should be identified, they are still in the usage mode only. And coming to that IPv6 addresses, IPv4 addresses should be replaced by means of IPv6, and how the IPv6 addresses should be identified, what are the advantages of a IPv6, what are the types of IPv6 addresses, and what are the disadvantages of a IPv6 addresses, as well as what are the advantages of a IPv6 address, what are the disadvantages of a IPv6 addresses. So, at finally the students can able to learn based on the internet control protocols, and under the internet control protocols, the two types of addressing modes like IPv4 as well as the IPv6. I hope this video should be benefited and useful to the students. Thank you one and all.
Like, share and subscribe. Hit the bell icon for more updates.